proof by deduction. A statement is proved to be true based on well-known mathematical principles. So let's have a look at some well-known mathematical principles. So if n is any integer, then 2n is an even integer. Something even plus 1 will give you something that's odd. You could also write this as something even minus 1 will give you an odd number. Square numbers, consecutive integers. So if we start with n as our first integer, we add 1 to get the next one, add 1 again to get the next one, and so on. Pythagoras' theorem. Lines are perpendicular if they're gradients, multiply to give minus 1. If there are no roots for a quadratic system, then b squared minus 4ac is negative. And we can use any trig identity, and so on. The Edexcel exam board specifications state for proof by deduction that you need to be able to prove examples like this, where n squared minus 6n plus 10 is always positive. It says prove that, or they'll use the words show that, and it's the most commonly used type of proof throughout the course. Here's another example, show that the sum of the first n terms of an arithmetic series is given by this formula. So again, they might say prove that or show that. So the difference between the squares of any two consecutive integers is equal to the sum of those integers. So we have two consecutive integers, and this is the sum of the consecutive integers, which gives 2n plus 1. The difference between the squares, so we have to square each of these integers, and then we have to subtract, so it will be the square of this minus the square of this. Expand the brackets, simplifying, and we get 2n plus 1. So the difference between the squares is 2n plus 1, the sum of the integers is 2n plus 1, they are equal. So we have proven this. We have to prove that this quadratic expression is always positive. So we use the completed square form, and in the completed square form, the x minus 2 squared can never be negative. The lowest value of x minus 2 squared is 0 when x equals 2. So this is always greater than or equal to 0. So if we add on 5, the whole expression has a minimum value of 5. So we have proven that it's always positive. The sum of two odd numbers is even. So if 2n plus 1 is one odd number, then I need to use a different letter for the other odd number, and then we add them together. So we simplify, and these are all multiples of 2. If we take the 2 out, then we've got 2 times something, so it's an even number. M plus n plus 1 is an integer. 2 times the integer, we just have a multiple of 2, therefore even. So we've proven this. We have to prove the sum of a positive integer and its square is always even. So first case, let's assume that the positive integer is even, because this positive integer can be even or it could be odd. So in the case where it's even, our positive integer is 2n, an even number, and then its square, so you put it in brackets and square it, is 2n in brackets squared, and the sum, so we're adding them. Okay, if I multiply the brackets out here, these are both multiples of 2, and because it's a multiple of 2, it's even. Okay, the second case, where our positive integer is an odd number. Okay, so we have an odd number plus the square of the odd number. Expand the brackets, simplify, collecting like terms, and these are all multiples of 2. So we have proven our statement that the sum of a positive integer and its square here and here is always even here and here. Okay, we have to prove the product of 3 consecutive positive integers is a multiple of 2. So if the first of these 3 integers is even, so if we start off with 2n, the next one will be this plus 1, that's the next integer, and add 1 for the next one, we've got these. So, and it says product, so I'm multiplying these 3 together, and now I have to show that we have a multiple of 2. So I've taken out 2 from this bracket and I've put it on the outside, so what we've got is 2 times all of this. So that's a multiple of 2. In the second case, if our first integer is an odd number, so here's the first one, it's odd. To get the next one, I'll add 1 to this, so I've now got 2n plus 2, and I add 1 again to get the next one. And as we did here, the 2n plus 2 this time, so I'm looking at this particular integer here, I can take out 2 from this bracket, leaving n plus 1 inside. The 2 that I've taken out I've put here. Again, it's 2 times all of this. So 2 times something will give us a multiple of 2.